exists, and then like real number like 1, 2, -2, 1.2. An imaginary number, I think it's like a number that's like not possible. So maybe
Well,
like the square root of -1.
So to put it simply, real numbers are those numbers which can be spotted on a number line.
Okay.
So even if you take root 2, what is that? 1.41 something. That can be approximately spotted on a number line.
Okay.
But when you talk about root -1, you cannot plot it on the number line. So that is the difference between real number and an imaginary number. So real number, a number which lies on the number line. Imaginary number, we don't know where that lies.
Okay.
Certainly not on the number line.
Okay.
Okay. So this is the quadratic formula. Do you see any square root here in this formula?
Yes.
There is a square root, right? So
Yes.
basically, see what happens if this value becomes negative. Let's say -1.
Then it's x has no solution.
Or we say imaginary solutions, right?
Okay. Yes.
So basically, whatever the quantity which is inside the square root, I'm not talking about outside, but the inside is important.
Okay.
So that determines the nature of roots. Roots means what?
Roots means you multiply one number by itself and it equals another.
See, roots means zeros, solutions, synonyms. X values, x intercepts.
Oh, okay. That roots values. Okay.
In quadratics, roots means x values. These
Okay.
x values.
Okay.
So there are two roots, right?
Yes. Yes.
Plus and minus. Okay. Nature of roots is determined by the quantity which is inside the square root, which is
Uh,
the quantity which is inside the square root.
b squared minus 4ac.
B square minus 4ac. We have a name for this b square minus 4ac. It is called discriminant. Capital D. Or in some textbooks you might find it as delta. Delta for discriminant. So
Okay.
yes, for simplicity D. So if D discriminant value is positive, roots are they imaginary?
No,
If this inside quantity is positive, it will be
it will be a real number.
real number. And if it is negative,
Imaginary.
imaginary. So D positive means roots are real. Okay.
Oh.
There is still, let's say if D is less than 0, roots are imaginary. Okay, less than 0, no, less than 0, greater than 0. What if D is equal to 0? Do you understand?
Then
0 is here. Less than 0 we discussed, greater than 0 we discussed. What exactly at 0?
then it's real.
Real. What is happening when discriminant is 0?
That means the square root is 0 too. So in general there is nothing.
So this is 0. So what is the answer for x?
Negative b over 2a.
Negative b over 2, right?
Yes.
See, if x is equal to negative b by 2a or d equal to 0, see, it is a quadratic equation, right?
Yes.
Technically, there should be two solutions. But how many did you get here?
We got one solution.
But it should be two, right?
Yes.
That means there are two roots here, but it is just that those two roots are equal to each other. So d equal to 0 means equal roots. This is important.
Okay.
Equal roots. And if they ask what is the value, means you can say minus b by 2a. So, okay. Is this a real number? Minus b by 2a?
Yes, this is a real number.
So equal roots and real numbers, correct?
Correct.
Okay. But here also it is real number. How can you distinguish between this one and this one? First case and the last case? Did you understand the question?
How can we distinguish between d is greater than 0 and then d is equal to?
Yeah. Here also roots are real. Here also roots are real. The key difference is when discriminant is positive, you will get
Two solutions.
two solutions.
Okay. And then if it's 0, you get one solution.
One solution, but equal roots. There will be two solutions only. It is just that equal roots. Single answer.
Oh.
They pair with minus and with plus.
Okay.
So roots are real and, to put it simply, distinct, not the same.
Okay.
So roots are real and equal. And d less than 0 means imaginary. So these three cases are important.
Okay.
In the previous class, we have discussed how to do factored form and how to solve quadratic equation also
Yes.
using factored form. Do you know what is the vertex form of quadratics?
Yes, I do. F of x equals a. Okay.
So this is the vertex form in quadratics. There are three forms in quadratics. First is what?
Vertex or quadratic.
In quadratics. So this is also quadratic. If you write like this is also a quadratic. It is just that this is called factored form. This is called
vertex form.
vertex form. So there is also one other thing. You can also write like this, right? X square plus px plus c.
This is quadratic equation form.
This is general form.
Oh, general. Okay.
Or standard form.
Oh.
Basically, just like how you might have learned in lines. Standard or general form, slope intercept, point slope, right?
Yes.
Okay. So if I write something like, let's say, f of x is equal to x square minus 1 is in what form?
This is in vertex.
Vertex. Okay. But is it in standard form also?
Yes, yes.
So standard comma vertex. Okay, let's say find the coordinate of vertex for this.
Okay. Vertex is negative 0, -1.
Hmm. And what is the value of a?
A equals um 1.
In this. So a into x square, right?
Yes.
1 into x square, that
1.
1. So even if you look at the standard form, something like ax square plus bx plus c, right? And if you
Yes.
look at the vertex form, this a and this a are same. If you convert this general form into vertex form, then the a you see here, this a and this a are same as.
Okay.
So in the previous question, this both in vertex and standard form. So a into x minus 0 whole square. So 1 into x minus 0 whole square. Or ax square plus bx plus c. A is still 1. And what is the value of b here?
0.
See? A, B, C. C.
C is -1.
Negative 1. Okay. Is this graph upward or downward?
This is an upward graph.
Because
Because A is non-negative.
A is positive. See, we don't take. So, what is meant by non-negative? Non-negative means what?
Positive. Or non-negative means 0 or positive.
Yeah, basically not a negative number. So 0 or positive. See if what happens if a equal to 0? In ax square plus bx plus c, if a equal to
Then
0,
it's just a linear line.
linear line. So chapter name is what? Quadratic, right?
Yes. So it's just only positive. If it's positive, it's upright.
So you automatically try to impose a restriction that a is not equal to 0. So this is a quadratic when a is not equal to 0. So these are some assumptions which we walk upon on. Yeah. So a is positive here. So that is why graph opens upwards. A positive means it smiles. A negative means sad face like this.
Okay.
Let's say there is a question. Let's say if f of x is equal to 3x square plus bx plus 5. Given that f of x has real solution, what is the possibility of b? What are the values of b?
Have to be negative.
D discriminant value has to be greater than or equal to 0, right? The real solutions.
Oh, wait. So then 0 would have. I mean, sorry, not 0. B would have to be
What is the formula for b?
B squared minus 4ac. So has to be greater. B has to be non-negative then.
Yeah. So basically, you use this formula now. B has to be greater than or equal to 0, right? What is B value here?
B value non-negative. Non-negative.
If B is this only, B only, right?
Yes.
A is
So 3,
C is
5.
so D greater than or equal to 0. So B square minus 4AC greater than or equal to 0, right?
Yes.
So B is B only. Minus 4 into A value into C value. This has to be greater than or equal to 0.
Yes. Yes.
A is 3, B, C is
C is 5.
5. How much is this product?
This is negative 60.
So B square minus 60 greater than or equal to 0. So B square is greater than or equal to 60. Okay.
Okay. Okay.
So can you think of some B values?
B could be like 8.
Or root 60,
Yes, or root 60.
8, 9, 10, 11. So many are possible. So the inequality is this.
Okay.
So we'll talk about how to solve these types of inequalities later.
Okay.
Let us first understand the basic before that. Let's say if I write x plus 3 is equal to 5. What is the value of x? Wait,
Uh, X is equal to 2.
okay. So similarly, if I write x plus 3 greater than or equal to 5. So you solve as if there was equal to sign. Okay.
Okay.
So x is greater than 5 minus 3. 2. Okay. And one thing to note is, let's say if minus x plus 3 is equal to 5, x is how much?
X is negative 2.
Let's say if minus x plus 3 greater than or equal to 5. How can you solve this?
X is less than or equal to negative 2.
So basically minus x is greater than or equal to 2, right?
And the sign flips.
So for negative values, the sign flips. I think this was taught in algebra, right?
Yes.
Okay. So there is a difference between this answer and this answer. Sign flips. Equal to is there only. Equal to is not bothered. This equal to sign.
Yes.
So that's about linear inequalities. Let us try to understand about quadratic inequalities.
Okay.
Let's say if they give a quadratic expression like this and they say is greater than or equal to 0. how to solve for x. Can you think of
Oh,
some values like trial and error? Yes. Okay, 2 works because this becomes 0. So it is satisfying this equal to sign. See, if I write 2 greater than or equal to 2, is this true or false?
true.
But if I write 2 greater than or equal to 2, this is
False.
false. See, even though greater than symbol fails, 2 greater than 2, this 2 greater than 2 fails, correct?
Yes.
It is still satisfying the equal to condition. So when we say greater than or equal to, so I have greater than or equal to. So even if you fulfill one condition, this becomes a truth statement. Okay.
Okay.
Yeah. So the point is x is equal to 2 is also valid because for this the value becomes 0. So 0 greater than 0
Oh.
equal to 0 is valid. So anyways,
Okay.
so there are certain values for this the quadratic is greater than or equal to 0. See, what if there was 100? X is equal to 100. Will this be automatically positive?
Um, this would not work.
X is equal to 100. See, 100 square minus 500 plus 6. Positive or negative?
This is positive.
Positive, right? Any doubt?
Yes. I mean, no, no.
Subtracted just a
Okay.
small number 500. Will still be
Yes. So
positive value.
yes.
So there are certain values of x for which this inequality stays true, for which this inequality stays true. So what is that specific range?
Um, that would be any number.
Yeah, that is the question for this. That is the question. So let us try to understand. Hmm?
Okay. Oh, sorry. Yes, we can continue.
Any number?
Any number greater than 3.
3. But what about the left side? Do you have any values? See, any number greater than 3 you have said, right? There's
Yes.
also 2 here in between that is also valid. So if you say any number greater than 3, it is still incomplete. The answers, it is not full answer. There is a 2
Okay.
which was behind. So who knows? There might be still some numbers, correct?
Yes. Correct.
Which could satisfy the inequality. So
Yes.
how to calculate that mathematically? By not doing the guesswork for every single question. That is the point.
Okay.
So the question was like this. So first, for quadratic inequalities, break this down into linear factors. When sounds complicated, but it's basically factored form. So break this down into factored form,
Okay.
right?
Yes.
So right there, drop this question as it is, but in terms of factored form. So x minus 2 into,
X minus 3.
hmm, is it equal to 0?
It's the
Greater than or equal to 0, right?
yes.
So There is a trick to solve this. So you first plot the critical points as if x is equal to 2 and 3 roots. So the first step is factored form.
Okay.
Second step is plot roots. Or roots of linear factors. Linear factors means what? Factors. These things.
Yes.
So what are the roots? Zeros.
The zeros are 2 and 3.
Or roots. So 2 and 3. On the number line, basically. Plot means what? So 2, 3. Okay. So this is the step number 2. Step number 3 is check the A value. Whether it is positive or negative.
Okay.
In this case, what is the answer?
Positive.
A is for A positive. There is one case. For A negative, there is another case.
Okay.
So for A positive, okay, we have drawn the number line already, like this. So we start from the extreme right, okay.
Okay.
So this interval, so this number line has been divided into how many parts now?
3 parts.
3 parts. This region, this region, this region. Total 3. So for positive A, start from the extreme right. This is the region, correct?
Yes.
We put plus symbol, okay,
Okay.
and minus plus. Okay, this is for quadratics.
Okay.
So plus. So in this region it will be plus. In this region it will be plus. In this region it will be minus.
Okay.
So automatically this method gives us answer for both conditions. When it is greater than or equal to 0 or less than equal to 0. You can directly check here.
Okay.
So the method is the same for both. Even if the question gives something greater than or equal to 0, or even if they give this as less than or equal to 0. Same process.
Okay.
That is for positive case. Okay.
Oh,
A is positive. For negative, it's also a bit similar but different. So the sample space, so the sample is something like this.
okay.
What did we do earlier actually for A positive?
Earlier for A positive, we
Here, what did we do on the number line?
oh
So we started from the extreme right, right?
yes.
We have started to mark plus, minus, plus, alternative symbols. So here on the extreme right, we start with a minus.
Minus.
So minus, plus, minus, alternative symbols. Plus, minus, plus, minus.
Okay.
So if the question was something like, let's say, so here it is A negative, right?
Yes.
Because for this also, if you do it properly, the roots will be 2 and 3.
Okay.
So greater than or equal to 0 means this range we have to consider.
Okay.
Less than or equal to means this range and this range.
Okay.
And that's it.
All right. So okay.
Discuss the difference between greater than or equal to. How do you write the interval notation? What brackets do we use for greater than? And what brackets do we use for greater than or equal to?
So for greater than, we use this. Greater than or equal to, we use this.
Yeah. So square brackets, curve brackets. Okay, we have discussed that. So this is about quadratic, solving quadratic equations.